Welcome to In 5 Minutes. In this video clip, we will discuss the demodulation of SSB signal. It can be done in two different ways. So we will discuss first the concept behind SSB demodulation, concept number 1, and then we will look at the receiver, a proper receiver block diagram which uses this first method of demodulation. And after that, we'll discuss second method and second receivers. So there are two methods and two receivers for SSB demodulation. Alright, so let's discuss the first method and the first approach. We will first discuss the concept behind this particular demodulation process. It is very simple process. We have the product modulator, and as we have already discussed this so many times now, the product modulator is nothing but the circuit of balance modulator. Look at the two inputs that we have to the product modulator. The output of product modulator is nothing but the multiplication of the two inputs. The first input is the received SSB-SC signal, S of t. It is multiplied by the carrier signal cos 2 pi fct. It is the carrier signal that was used on the transmitter side. The same carrier signal we require on the receiver side also. There are two ways in which you can generate this carrier signal. You can either generate it locally using local oscillator, in which case it may not be exactly same as the carrier signal used on the transmitter side. Or you can also extract this carrier signal from incoming signal. Now that is only possible if the incoming signal is SSB-RC signal, because if you remember, in SSB-RC signal we attach a very small amplitude carrier signal to SSB-RC and then transmit it. But if my received signal is SSB-SC, then there is no carrier in the received incoming signal, and hence in that case I will have to generate carrier locally. Right now we are not much interested in how the carrier is generated. We will discuss that in the specific block diagrams of receivers. Right now let us simply assume that the carrier in the form of cos 2 pi fct is available to us. S of t being a single sideband signal, I can write it in the form cos 2 pi fc plus fm. So I'm considering the upper sideband representation. It is multiplied by the cosine representation. For simplicity, I have assumed both the amplitudes to be equal to 1. So we get cos A into cos B form, which will be nothing but half cos A plus B. So let's say what is going to be the sum and the difference of the two frequencies, because we have cos A into cos B, which will give us cos A plus B and cos A minus B. So when you add the two frequencies, you get cos of 2 pi. It is fc plus fc will make it 2fc plus fm. Fm remains as it is, t, plus the second term will be a minus b. Now when you subtract b from a, when you do a minus b, you can see fc will cancel out, so you will get cos of 2 pi fmt. So what you have got at the output of the product modulator, this is nothing but my v1t, is the two frequencies, out of which the first frequency is 2fc plus fm, which is very high frequency signal, whereas fm is my AF, the low frequency signal, which is also the audio frequency. I want fm to come at the output side because that's my modulating signal, m of t. I don't want the first signal to come at the output side, so we simply use a low pass filter. After you pass the signal through a low pass filter, the output of low pass filter will be only the second term, which is cos 2 pi fmt. So this gives me my original modulating signal back. So this is the first very simple concept based on which SSB demodulation takes place. So all we do in this concept is nothing but multiply the received SSB signal with the carrier signal. If the received signal is SSB suppressed carrier, then we have to generate the carrier locally, multiply the two signals and pass the signal through a low pass filter. This will give you modulating signal at the output side. If I want to have a perfect demodulation or less distorted output signal, then I should not use the carrier generated locally. I should extract the carrier from the incoming signal. That is possible if instead of SSB-SC, SSB-RC, which stands for single sideband reduced carrier signal, if SSB-RC was transmitted from the transmitter side. Let us now look at the specific receiver block diagram which works on the first concept of SSB demodulation.